Hey everybody, we got so many people here. We got Nolan, we got Sierra, we got Aaron, we got Jessica, we got Michelle, we got Hannah, we got Grace, we got Leela, we got Knox, we got Matt, we got Olivia, we got Cooper, we got KP, we got Riley. Good to see everyone. Mubot is now awake. I'm now awake getting my coffee. The bunnies are in here. We got the pest guy coming by today, maybe. So the bunnies are in this room. They're in their cages though, so you can't see them. They're over there. I might hear them thumping though. I don't know. I don't know if they want to hang out with me this morning. I don't know. Bunnies in the chat. Mubot's putting some bunnies for us right there. But how's everyone doing? We're going to start with some questions. I got emailed a 201 question, so we might start with that. I'll put a little music on here. Someone said this is the sad music. The sad music. What questions are there? See what chat is saying. Can we do something of user input problem? Yeah, 475 user input. Yeah. We're going to do some competition today. Some competition in 475. We'll do user input next. I'm going to start with this problem. Thank you to the person who messaged me. I'm having trouble with chapter 7. Isabel, drop anything in the chat. Let me know. 474 user. Oh, you're talking about 474 functions. Question 3 and 4 on lab 3. We're going to do lab a lot today. New, fresher, great. Did my Pearson go down to improve their platform? Is that's why it says new, fresher, greater? They're like, oh, check this out. We have improved our platform, but we had to go down for 72 hours to do it. Can you go over the data lamp? That's it. Nolan, you got it. That's one of the first things. The student emailed me that. Let me take these questions right here. We could do one of those. Riley, I bet that'll really help. Stat 201, Chapter 5, Part 2. And this is steer weights. This will be the David M. Lane. Jessica, good to see you here. Lab 3, another person saying that. Good job, Grant, right there. Let's take question 3. So BS 474. Lab 3, question 3. Oh, you're saying 4B. We could get to 4B also. Chapter 7. So Isabel, drop something chapter 7. We'll do chapter 7 here. Step 201. Chapter 7 regression right there. I got that spot for that, Isabel, so let me know. And KP wants some input stuff, which we'll probably do in 474 right there. We got some stuff. Keep saying what you want us to do, and we will do it. Thank you so much, everyone, for being here. It gives me a lot of energy when I come in and I see, like, the 20 students here ready to go. I jump in, I'm a minute late, don't tell anyone. And then we start up and everyone's like, we got questions. I'm like, let's do it. Okay, so here we go with some David M. Lane. Let's take a look at those bunnies. Here we go. Okay, so this is a problem where you would use the David M. Lane applet. Now, the David M. Lane applet basically allows us to do the work without having to do it by hand. Now, on the test, ooh, fat and cheeseburger, you bet. So the cheeseburger calorie count. Now, the David M. Lane does the work for us, but we need to know how to do the work by hand. Okay, so let's talk about how to do the work by hand, and let's take a picture of the problem. You ready? We're going to do this by hand first, and then we're going to find the actual values with the David M. Lane. So it says steer weights have a mean of 1,155, and then a what? What is 84 in this problem? What does 84 stand for? It's the second number. And so what does 84 stand for? So you see where it says N. N means normally distributed. Standard deviation. Great job, Isabel, right there. So this means normally distributed. That's what that means. That's the mean of the distribution. And that's the units of standard deviation. So when you see the first letter, it just means normally distributed, the shape of it. And then the first number, 1,155, is the mean, and then the next is the standard deviation. A little color coding there to help out, and then we're going to do a drawing of it down here. Okay, so now we're going to put the mean at the center. I'm going to disappear right here. Tell me the next number. I might have to decrease my handwriting size. Tell me the next number going up, or tell me the mathematics to find it. Tell me how to find the next number above the mean. Great. I think people are getting it right there. Add right there. Add it. Grace. Great job right there. Putting 1 points in the chat. Great. We're throwing 100 points. People are giving all those answers. So that is the unit increase right there. The standard deviation is the unit increase. And so we're going to go 84 and 1239. And we might just only have to do Usually you do all of it. The lowest 20%. Okay, we are going to have to go down. So minus 84. We're back at the mean. Minus 84. 1071. So many bunnies. Bunnies, you hear that? They're talking to you. If I could put them back after the Orkin guy comes by, or gal. I don't know who's it going to be. They call him the Orkin man, but anyways, here we are. Now, the reason I did it this way is you'll see in a second, we don't need all the numbers. We're going to use the David M. Lane to find the exact answers, but I want us to think about where these answers would be. You ready? This is the important knowledge for the test. What percent of area is between -1 and 1 standard deviation? What percent of area is between -1 and 1 standard deviation? So between 1 standard deviation up and 1 standard deviation down is 68. Jessica, great work right there. So if this is 68%, if that's 68%, then how much area is above 1 standard deviation? And I call this the inside-outside trick. If 68% is inside of here, like if this is 68%, then what is outside? I think the people are saying the above, right? So 32% is outside, meaning 16% is, great job, everyone following along. Then 16% is above. So 68% inside, subtract that from 100, that's 32, divide by 1/2, that's 16. So this is 16% right here. Now the reason this matters is because if this is 16%, then this spot right here is the top 16%, which means the top 10%, would be somewhere over, and we'll put an X, somewhere over here. Does that make sense? That the top 10% has to be a little bit above the top 16%. Who's following me on that logic? Like if that's where the top 16% is, then the top 10% is maybe about somewhere there. I'm not saying exactly where it's at, but it has to be further over because this is the top 16%. Does that make sense? Got it. Now, the lowest 20% is going to be where? A little bit above what? The lowest 20% is going to be a little bit above what? And this is how we understand what the curve is telling us. So give me a number and say, well, then the lowest 20% would be a little bit above what? Close, Sam. Good guess, Sam. 1071. And the reason 1071, let me grace a mod right here. 1071 because 1071 is the lowest 16%. Does that make sense? So if this is the lowest 16%, like 16% of the curve is below this line, then the lowest 20% would be over here somewhere. So it has to be a little bit above 1071. And it's probably about over here. So this is answer A. This is answer B. And then answer C. Oh, yeah, no, good work right there, Grace. You switched here, like, wait a minute, someone else said 97. So now the last answer is the middle 68%. We're going to do it in a different color. Bunnies, I'm sorry I'm being loud. So the middle 68% has to be contained within the what? The middle 68% has to be contained, or middle 40% has to be contained within the what? And sometimes test questions do these sorts of like logic things where you might have to figure out like an ABCD answer choice using a logic like this, and then we're going to graph it and show the exact answers here in a moment. So the middle 40% has to be contained within the what? So if we have, think of this 68%, then wouldn't the middle 40% be a little smaller? Does that make sense? Like 68%, 40%, does everyone follow that logic? So the middle 40% would have to be something like, we'll do a line right here, it has to be symmetric around this right here. So the answer for C has to be the middle 40%, has to be something like that. Does that make sense? We've now logically kind of figured out where all the answers would be. We could take guesses at these, but sometimes people wonder, how do I take those guesses? Well, let's just show it visually right here, but then let's find the answers. Now that we've drawn, we know how to use the mean, we know how to use the standard deviation, and we also know a little bit about the empirical rule. We're going to get the answers to the question for the steer question. And keep those questions coming because we have time for enough more. The bunnies want to hear more questions. Bunnies. They're being weird. We're going to go here for the David M. Lane applet. I'm going to pull up both on the screen right here. Okay, 2 seconds to get screen oriented. And I might disappear so you can see both pictures on the screen. Okay, so if you look at this question right here, it says the top, well, first off, let's not use standard deviations, z-scores. Let's go in here and enter in the mean of the curve and let's enter in the standard deviation and take a look. The picture we have is identical to the one on the right. Now, the one on the right has more numbers on it. We went further down on this. It does all three standard deviations up and down, but let's see if our answer to A makes sense. For A, it says the area, the top 10%. Now, I did one thing wrong. We have to click on this button right here to do the area. Let's put back in the mean of 1,155 and the standard deviation of 84, and this time we can actually specify how much of the curve to shade. On this second button right here, you can specify the amount of the curve to shade. And does everyone see where we have A? Let me slow down, make sure everyone sees what we've done right here. But does everyone see how we got answer A right here, which is the area shaded? Does everyone see answer A on the screen? How are we doing? Does this make sense? We have now shaded this right here, and we have confirmed that the first answer is 1262.65. So 1262.65, that rounds to 7. There we go. So what would the exact answer be? The exact answer is going to be via the applet. So we can do the drawings right here. Got it. Nice job. So now the next answer, answer B, we could do a little drawing, is going to be right. Oh, B, we didn't mark it with a line. So B was right here. That's where we put our X for B. So B has to be this. And this is the best way to solve these questions right here. This will make sure you have that knowledge. You won't use the applet on the test. You might get pictures of it. Check out Canvas content for the way the questions might look. So you might get pictures of the applet on the test. The best thing to do is like do little drawings. The same question with IQs. You bet, Sam. We'll do that here in a little bit. You got it. I'll do that next because it's a good kind of bridge to do both of these right here. So we'll do that and then we'll do some 474. So now we go to the below and we go to 20%. Does our picture look very similar? Yes or no in the chat. Does our picture over here, and we said a little bit above 1071, and look at what the answer we get is. Our picture looks pretty similar, right? We figured out this spot, and then we said a little bit above it. So this is going to be the answer right here. We're going to round it to that 1 decimal. And then the last but not least question, great job, everyone. The last question says the middle 40%. So once again, we're going to shade this and try doing these drawings. I know the applet will give the answers, but try doing the drawings along with it, where you figure out that the middle 40% would have to be contained within the middle 68%. That's going to be the best way to learn these topics, to say, you know, that middle 40% has to be contained within the middle 68%. So it has to be something like this right here. And then when you check the answer, we go over and look, and we do 40%, and we go between, or we click the random button down there, we go between, and it looks a lot like our graphic. So now we can see it was between those numbers. It's 1,011,111 and 11199. I think so. We can remember that. So here we go with 11111, too many ones, and 1199. I think that's it. Let's check, and we got it right. There was one more question about finding the percent of the area to the right of. Yes. We used that one in the applet, and check out, we could do that one here in a little bit, Nolan. We did that one in yesterday's office hours, but we can do it again. We might have enough time, but we did that one, I think it was the first question. Yesterday's office hours are labeled. It might have been the first question we did. It's question 3. It's actually my favorite one. It is my top favorite question of the semester. We're going to speed run it real quick here. No, because then people are like, how'd you do... we'll come back to this one. I think. Okay, there was a question about the IQ one. Where is the IQ one? It's on the quiz, right? Okay, let's do the IQ question. Then we're going to do 474 next. And then we'll do 474 after that. And then we will do the the calories and fat one. Thank you so much, everybody. Tell which of the residual plots. Ooh. Residual plots go with the model. That's Stat 201, Chapter 7. Is that Chapter 7 or 8, Met? Residual plots with models. And then we're going to do another Chapter 5 right here. Stat 201, Chapter 5, Part 2. It's Chapter 7, that's what I thought. Chapter 8 is Regression Wisdom, which is like building IQ and percentiles. Okay, let me go find that IQ and percentiles question. It's on a quiz, so I have to look around for it. Pop-ups were blocked. Try freehand grader. No, thank you. You broke my Pearson for freehand grader. So let's go find the IQ question right here. So if you're ever given a question that has you use the normal model, you first want to draw it out. So what's the first thing we do if we get a question that uses z-scores, the normal model, percentiles? What's the first thing we do? I might actually just pass it. What is the first thing we do whenever we get questions with z-scores, normal models, percentile, empirical rule, you name it? It wants the area between two numbers. What do we do? What are we going to do? First thing we're going to do, does anyone know in the chat? You get a question like this right here. What's the first thing you do? You'll see the question in a second. Let's go check out the question. Cooper, Sam, and Grace note, we're going to draw it out. As Joey one time said on Full House, he was like, draw it out. I think that's how that quote goes. I don't know. I only watched a little bit of Full House. Here we go. Here's the question. Let's bring it over to a Word document. Can you check if my short code makes sense? Yeah, no, I can check here a little bit. You bet. We'll try to do it in an in-between scene. I'll try to take a look at it real quick right here in an in-between. Thank you so much for everyone messaging on Discord, getting all those answers, working hard right there. I appreciate it. I'm usually like hopping around between messages, maybe like calls and stuff like that. It's pretty quick. So with this right here, what do we have right here? I'm going to highlight things in different colors, and you tell me what they are. Explain to me what this notation means. I'm going to start writing it. Explain to me what that notation means. You can say like yellow means this, blank means this, and I'll give you hints down here on the bottom, like visual cues. What do these things mean? What do they mean? For the 2-1 test, we'll be able to use any outside programs like the website. Nope. You'll want to draw it like I'm drawing right here, and the questions will be formatted in such a way that you'll be able to get them. Definitely check out Canvas content to understand, and great job right there, Jessica and Hannah. Check out Canvas content for great ways to know what the test questions might look like. Canvas content is going to be your #1 way to say, how are they going to test me on the test? So if you're able to do the Canvas content, you have to watch out though. Like if you use all 5 attempts and you finally get 100 on the 5th attempt, realize that you get 1 attempt on the test. Like sometimes I've had students be like, oh, I aced the Canvas contents. And then like, I talk to them and they're like, well, it took me all 5 attempts. And I'm like, well, remember the test, you get 1 attempt. So you want to kind of like think about how, we could use it to ask different questions. Like if I said to you, I'll ask a quick question right now, that could be a very short question on the test. What % of people are expected to have IQs above 132? And if you know how to do this chapter really well, you'll notice why I said 132. According to the empirical rule, so this is the way a test question could be, according to the empirical rule, what % of people are expected to have an IQ above 132? It's not on this question. How many questions? Like 42, something mid-40s, I think. Without looking at it, we usually do about 40-ish questions. Serenity now. You doing okay, man? He's a bot. Are we going to do? Yeah, let's do we might do it tomorrow. Maybe I'll do it tonight. I'll do it tomorrow. I'll announce it today and we'll do it tomorrow. It's been a crazy week. My Pearson going down totally made everything crazy. Who knows the answer to this question right here? Who knows the answer to this question? This is a really great job right there. Sam, how'd you get that, Sam? How did you get that? Close, Jessica, very close. So 2.35 is in the area under the normal curve. 2.35 is the area in between 2 and 3 standard deviations. The area above 3 standard deviations is 0.15. I can barely write that small. Exactly, there you go. 2.35 plus the 0.15 right there. So I see what you're doing. You might have a picture of it. Great work. Excellent work, Jessica. More points in the chat. So what we need to do, we'll look at our question we wrote too, is put the mean at the center and go up a standard deviation. Bunny, is you okay? And 16 minus that, so 68, I think. And 16 minus that, 52. There we go. So we have here the graph, and the way we found our answer is I used z-scores of what and what. Well, the top z-score is a z-score of what? We're looking at our new question that we made up. This is our made-up question for a test question. The 132 is a z-score of what? The 132 is a z-score of what? That 132 is a z-score of what? So this is the fake question I made up to kind of talk about how a test question. It's a z-score of 2. And then what area is between -2 and +2? What area is between -2 and +2? So what area is between -2 and +2? Yeah, we'll be doing some for loops here. 95%. And then if 95% is between -2 and +2, then that means the answer we're looking for, which is the above, is, say it with me again, it's half of the remaining outside, 95% inside, 5% total outside. So then the remaining area, or the top area, would be 2.5. So this is a good way a test question could be done to use your knowledge of the empirical rule, so that way you don't actually have to use any calculators. Now, if we do use the calculators, we might show you pictures of them. So that was just kind of a random test question right there, where we're kind of just, solving a question we can solve without the applet. There are questions like that on the test that use the empirical rule, so no applet required. The numbers below this are called the what? So those are known as these scores, or this is known as the standard normal curve. The standard normal curve has blank scores for the center and for the standard deviations up. This is the standard normal right here. It's called the standard normal because it has a mean of 0 and all those values are what's. It has a standard deviation of 1, which is the unit difference right there. That's the standard normal. The more you write these things, the more you practice them, the better you get at doing it. Those are what scores. Those numbers down here, which tell us how many standard deviations something is above or below, are what scores. Those are what scores. How many standard deviations something is above or below? I mean, like 116 has a this score right below it. It's 1 for its blank score. Z score, Sam knows right there. Those are Z scores. Great job, Hannah. So what percent of people are expected to be over 75? So the first question right here is going to be, it's a Z-score of about -1.5. Now, if you were looking for a number on the test, what would you put? If it wants over 75, is that a lot of the curve? Over 75 is probably about 93% or so. It's probably about 93%. The next one says under 95. So we'll put A right here, and we'll put a little arrow to the right. And then under 95, that's going to be a tough one. That's B, put a little arrow to the left. And then between 112 and 32. Ooh, we can, it's a little tough. So C is between. This is a great way to draw this out before you start doing it with the applet. Does this make sense what I'm doing? Like, I'm practicing how to draw on the curve, understanding what z-scores are, and I could probably estimate these areas and take decent guesses at what they are. Let's pull up the applet right here and take a look and see if we can get the answers now. So once again, know how to use applet pictures, know how they should look like. The more you can draw these things with the applet, the better you'll do. So I'm going to disappear right here, and let's take a look at the answers. So with this right here, we want a normal curve, and we're going to enter in the values this time. We're not going to enter in a percentile because we're going to get the value and get the percent instead. So here's the area. And so let's enter in 116, and we're going to go the area above 75. So once again, we want to confirm that it looks a lot like our picture. So our picture, we'll do a little blue shading right here. We have now drawn a nearly identical picture to it, and the answer is 94.09%. 94.09%. To one decimal, tell me if you get like a little decimal error here. 94.1, that's one decimal. Next one says the area below, and it's below 95. And so there's the area below 95. Let's confirm with our picture. And there's our picture right there. The area below 95. Good stuff right there. And that is 37.7. Hopefully I'm rounding everything properly. Can you do, yeah, we're going to do some of that to them. You bet. That is next on our list, and we're also doing that during class today. And so next, we have the area between the area between 112 and 132. And that's 20.4%. So far, the exam, you would be given a question like, but probably, yeah, you can use empirical rule, and we can also give you pictures. There's like a medical question on the Canvas content. There's a lot of good examples on the Canvas content that show you exactly what we might be trying to check you, like your knowledge with. No, good question. Thank you for asking, Grace. Keep asking those questions. On the exam, you would be given questions that might show you pictures, and then you might have to use the picture to find the answer, like mark the values. And I would just draw on the picture. Like I would write it down, and I would start drawing on it to kind of interpret the values. So check out the Canvas content. We could do some Canvas content here if you'll want. We're going to go and do a for loop question, or the function question, I think, for the lab. So keep asking those questions. We're going to do some 474. I think no one had a quick question. There was a quick Discord question. Someone said, can I check the code? Let's see. Might have to look later. Is it having an issue? Might have to check that out later. Let's see, we're gonna do the lab question. We're doing some lab. Was me. I looked and what's the code doing, Noah? Sorry, Noah, I said Nolan. What is the code doing? What issue is the code having? We're gonna do some 474. Sorry, bunnies. Let's see. Been grading a lot today. Okay, we're gonna get the lab going right here. Might have time for 3 and 4. Okay. Good to see you here, Rod. Hello? I've got the door locked. I don't think they have a key to do the deadbolt for the Orkin person. Okay, let's go do lab 3, question 3. Here we go. Epic music for today, Tuesday morning. You bet. This is like one of my favorite ones. Pretty chill. Good music for today. I gotta remember, I got like, I don't know, I've got like 10 good songs, I think, on here. They're all YouTube compatible. YouTube has a music library you can use. I actually heard that in someone's video with like million-ish views. It's a guy who like reviews a bunch of stuff, and I heard that in the background. I was like, I know that one. I took that one from the music library too, because YouTube gives us music we can't get copyrighted with. Yay, no copyright claim on that. Can we copyright strike stat 201? No. Let's load up some programming data right here. Let's set the randomness. This sets the randomness for when we're running our code. So that's the RNG con. You've probably heard of RNG. It stands for random number generation. So that way, when you're generating random numbers inside of R, such as if you go right here and go to random normal numbers, we were just doing the random normal, you get the same number. And we could set the C. Could we possibly do, yeah, well, we were just doing some, Mackenzie, let me know. We were just doing some a moment ago. Drop those questions in the chat. We just did 2 questions. We did the IQ and we did the steer weight. Let me know which ones you're working on, and we can definitely do that. Be like, hey, can you work on this question? And we did one yesterday. We did the areas above and below the curve. Let me know which ones you're stuck on. We can check them out. Okay. So what you can do is you actually skip a little bit quickly through here. And let's go to question number 3. Function with a for loop. Okay, here's the big thing. How do we write functions in for loops? Now, this is counterintuitive. How do we write functions in for loops? How do we write functions in for loops? We start writing functions in for loops by not doing what? Let's see if anyone knows for 100 points. A little bit of a what? How do we write functions in for loops? Noah, perfect answer. I like that. You make a specific case. So you don't write the function in for loop. You get it to work one time, and then you turn it into a function or a for loop. So you don't start by writing the function or the for loop. You don't start by going down here and saying F is for friends who do stuff together. U is for you and me. N is for anywhere and anytime at all. And that's how we make a function. I think that's how the song ends. For loop works the same way with snippets, where you can get the basic code for it. Don't start by doing that, even though it's fun. Don't do that. So let's take a look at what the function wants us to make right here. Okay. Here we go. Function with a for loop. write a function called cumulative sum that takes an argument x. Okay, so it has an input x. So I'm going to go down here and I'm going to go and put x, and let's make a vector of numbers. Actually, they're giving us a vector right here. So let's go ahead and drop that vector in right here. This kind of gives me something to work with to take the cumulative sum of. So cumulative sum, I'm pretty sure I know what that is where it adds up each element to the vector and tell me if you were at 1, what would be the cumulative sum of 1? So think about how cumulative sum works, that it's going to do a cumulative sum of everything in the vector. What is the cumulative sum at 1? So that's the first thing in it. What's the cumulative sum right here? It's 1. Great job, Kirsten, right there. It's 1. What is the cumulative sum at 3? What is the cumulative sum at 3? So cumulative sum means we're going to add everything in the vector. What is the cumulative sum at 3? Because we're at the second thing now, so what's the cumulative? 4. And I think you get it right now. Last question, what's the cumulative sum at 6? See if you get the pattern right here. We might even have some 201ers being like, oh, I see it. The cumulative sum at 6 is going to be what? Because you're just going to add up everything to that point. It'll be 10. Does that make sense? Because it's 1 plus 3 plus 6. 1 plus 3 plus 6. Good work right there. So the cumulative sum is everything added up to that point in that vector. So what we want to do is we probably want to use positions to add up. So how about we go here and we do x, and then we go 1 through 1. Does everyone see right here? How about we do this? Now, what if I wanted the sum? Who can take this code right here? Now, write it properly that it'll take the sum right here. So write this code such that it'll take the sum of that. Try working with what I have in the chat. No worries, Audrey. Great work right there. Good practice. Try taking the sum of that. So try taking the sum of that. Try taking the sum of that. Because then we could find the sum at that. We take the sum of that right there. Great job, KP. Great work. Turn down the sound effect a little bit. Oh, I'm going to knock things over. Okay, sum of this. Okay, so now we have the sum of it. But we want to store this. Let's go right here and store it into something called, what does that do? What does that do? So we're calling a cumulative sum. So what does that do? And the function is going to be called cumulative sum. So let's just call it CS. There we go. We'll store that. So this creates a blank space, a nothing vector. Does that make sense? It creates a nothing vector, and I'm then going to go down here, and I'm going to store into it. But think about, when I run it the first time, where should I store into my vector I'm creating? So where should I store into my vector I'm creating? Where should I store into that vector? So I have a vector CS, and if I do this, or I'll show you, we're going to have a little bit of a problem. Because look at this, it's just changing the number. First position, that's exactly right. So we want to store into the first position of the cumulative sum vector. And then I want you to see, what do you think we've done right here? And I want you to look at the cumulative sum over there. So there's the cumulative sum up there. And watch what happens as I run this. You can see the cumulative sum is now finding the cumulative sum. What have I created? Who knows what we've created right here? Who knows what we've created? Who knows what we've created right there? We've done it. We've got it. Who knows what we've created? You know, he's about to appear on the screen. We found him. We created that skeleton. We found it. He's so excited. Skeleton has been found right there. So we got the skeleton. So now that we have the skeleton, we have to think about how do we put it inside of a for loop. So we're going to take the skeleton right here, and we think about how does this become a for loop. So now we get to write our for loop. F-O-R. And here it is. Now, when I put it inside of the for loop, we have to think about what this is going to go through. Well, it starts at 1 because it has to take the cumulative sum. But how long does it go? How long does the for loop go? Like, I should go 1, 2, 3, 4, 5, 6, 7, but that's not always going to be the same. People aren't going to always go the same amount. How would I find out how long this for loop needs to go to find the cumulative sum of that vector? I need to find the what of that vector they input. The length, great job, KP, right there. So when we go right here, we're going to say 1 through the length of x. Now the length of x is currently, you can see right here, it's going to do it all 7 times right there. Does that make sense? 1 through the length of x. And what do we need to do now is we need to put in a placeholder. Does anyone know what one letter I'm probably going to type for a placeholder? It's my favorite for positions when we talk about going through different positions. So what am I going to do for different positions? I'm going to type I. So this is just a placeholder that changes so that the first time my loop runs, and we'll show this right here, the first time my loop runs, line 57 is going to do what? We're just talking about what the loop does right now. Line 57 is going to do what? The first time my loop runs, line 57 is going to do one. Great job, everyone, right there. Line 57 is going to do what right now? Like line 57 will do what right here? What does line 57 do the first time the loop runs? The first time the loop runs, line 57 will do this. It's going to, great job, Kirsten. Excellent work. It's going to store 1 into I, then run the skeleton. But since I is 1, it's going to do store into vector CS, position 1, the sum of vector x, position 1 through position 1. Then it loops back up here, and it says I is now 2, and then it runs the skeleton again, and it keeps running the code till it gets to I is 7, and then it does this. Does that make a little more sense to see? We've written the for loop, we've taken the code, added it in as a skeleton, and then we can understand what the skeleton is doing. You can also check your for loop by using an I and just changing what I is to make sure your code runs. That's another way. Sometimes I'll pull out a for loop and kind of, I call this like manually running the for loop by changing the value of the placeholder. That's not how we run for loops because the for loop is meant to do the work for us, but you can check a for loop by pulling it out and then using a placeholder stored to the global environment and changing the value of the placeholder. And then you could actually check to see if you made the values. Ooh, something happened. I might not have ran it from the beginning. So here, wait, 1, 2, 3, 4, 5. That should be fine. 6. Ooh. What's happened? Is the vector x not long enough? Oh, x got changed. What happened? Let me run the for loop and see. Let's see. What happened? Okay. Let's take our vector x right here. See if it works properly. Was there negative numbers in there? It's not negative numbers. Sum of... What did I do? Let me think what's going on right here. Brain's like on like boop, 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 boop. Oh, wait. Kirsten, 100 points. Do you think there's an error, Kirsten? Yes or no? Do you think there's an error, Kirsten? Yes or no? We weren't changing x. We were creating the vector CS. We weren't creating... I don't think there's an error. We weren't changing... You notice right here it is working. We weren't overwriting x. We were changing CS. We were storing into CS. And so I don't know why I thought X. I was looking at it, I was like, everything makes sense theoretically. And they're like, why is it not changing X? Because we're not storing into X. And so Rod, good question right there. The length is currently 7. It's grabbing that for us. Rob pointed that out. Rod, great answer right there. It is length 7. And yes, very much so. And so that's going to find the length for us kind of based on whatever someone puts in. So if someone puts in a longer vector right here, then it's going to find the answer for us and do it through the length. So that can kind of change and augment or unaugment. Augment means to increase, kind of change depending on what the person inputs. So now when you think about this, if we turn this into a function, let's take everything we've written right here. Let's remove out where we input x. If we make this into a function, then we need to have it that a person would input what into the function. What is the one input to this function? What is the one input to this function? What is the only input to this function? What does this function need to run? What does this function need to run? What does this function need to run? What does it need to run? What would this function take to run? What would it take? So, well, it's going to find that first great answers rod right there. It's going to find the length of the vector for us. It needs a vector, right? It just needs to find the cumulative sum of a vector. So let's write fun right here, and let's put in a vector x, and then let's call it it's cumulative sum right here. Cumulative sum right there. And then we're going to take our code and put it inside of here. Now, our code is almost exactly, this is Control-Shift-A right there that reformats code. And it's mad because I don't have one more bracket like that. Okay, what happened? Oh, it's down there. Oh, fine. Then that should be in that spot. I just didn't reformat it down here. There we go. All right, because I was like, how did I lose that bracket? Lose your brackets, bad time. Okay, so we start the function right here by taking and making a blank vector. Next, we run a for loop, which goes through 1 through the length of x, changing what I is through those values, and storing into that blank vector in position 1 to start, finding the sum of the length of the vector x, 1 through the length rather, finding the sum of those elements 1 through whatever we've gone through. Now, we're missing one thing here on line 66, because this is a function, and how do we leave function world? How do we get out of function world? We have to what from function world a value. It might work if you change it up a little bit, but how do we come back? We return. Great job, KP, right there. We hit return, or we type return. We go return from function world, and that's going to return the vector right here. So let's try this, and let's uncomment out the code, and there we go. We've done it. We've done it. How's that looking, everybody? Is this making a little bit more sense? We just did a for loop and a function together in one. So happy together. But notice how we did this. I'm just kind of deleting my spaces. We write first one instance of it, and we get it to work. So we did a lot of kind of getting it to work on one instance. Good to see you here, Gustavo. We get it to work on one instance, and then we put it into a for loop, and then we kind of generalize it to work on a function. So remember, this does take one input right here. Was there another one? Did people want to do question 4? 474. Let me know, because we're going to do the calories and fat coming up here soon. Today's going to be a work day in both classes. We got contest in 475, and in 474, we're going to do even more of this. But we'll try to put some in this video here to give you some lab help. But did people want to do, was it question 4? Which other one? People said 4B. Do 4A and 4B. There's a lot. Bunnies are in the room hanging out with me today. The bunnies. Let's check out 4B, and then we're going to do the fat and calories. And Met, don't worry, we're going to do that residual plot coming up here soon. So let's check out BAS 474, Lab 3, question 4. I'm excited for the contest. Nolan, that's awesome. I love contests. I love competition. It's fun. Like you get to like learn from each other, and like, I don't know, maybe I watched too much Dragon Ball Z and saw Goku and Vegeta competing against each other. It warped me. My mind forever changed. Goku and Vegeta. The battle never ends. No promises how I'll do. No worries. Just have some fun. Enjoy. Learn from each other, learn from your group, ask questions, and we're going to post a lot of code, so that's going to be really exciting. Okay, let's find out right here. Function, writing, and aggregate. Now, aggregate's actually a really, really powerful function. If we were to go here and take a look at what aggregate does, let's load up reg class. Now, aggregate basically does a lot of things that we might use a for loop for, so it kind of helps with stuff. Let's take a look at this. Let's run data survey 10, because I love that data set. It just doesn't have, it has very easy to remember variable names. So we could go here and go to aggregate. I'll show you what aggregate does. The weight by gender and data equals survey 10, and then fun equals mean. There's the mean weight for each gender. We could go here and get the standard deviation, and there's the standard deviation. We could get the IQR, there's the IQR. We could get the median, like that. Now, what about if we add an extra thing right here and we do handedness, which everyone really cares about? We can get the median handedness for all the groups right there. So aggregate basically breaks apart a Y variable, like weight, by the x variables you divide it by and creates those groups. It aggregates them into groups and then does a function for each of those groups. So the fun right there is the function. So aggregate's really quick and powerful. Like if you want to find, let's create these different groups right here. Let's find the mean for each group. Super quick. Those male ambidextrous right there. Those are the heaviest of all individuals. Even better yet, we could just sort this. Will it sort? Do I tell it which vector to sort on? We have to do an order. It's a data frame. You'd have to order it by the rows and do weights, and we won't worry about ordering it. But the quickest way, if you want to order it, just go inside and take a look at it, and then just order it like this. It's the quickest way to visually do it. But you could use the order function, which is not part of this question. Just kind of wanted to show what the aggregate function does and how powerful and how quick it is. So let's take a look at what they want us to do. Writing a function called prop of donors that takes a single argument x, cool, nice and easy, and returns the function fraction 0 through 1 of elements in x that are equal to yes. Have the function output a warning saying x should be a vector of yes and no if there are no values in x that equal yes or no. Okay, so a warning is going to stop the function true or false. A warning is going to stop the function true or false. KP gets it right there. False. I need to do more quiz questions like this. It will not stop the function. It will not stop the function. So, won the poll. Yay, 100% votes. Okay. So let's take, do we have right here? Okay, we got a vector. Okay. So it is case sensitive. They want us to make it case sensitive. There's so many ways to do this one. Okay. Let's store it here, x, and run this. And now we want to know what percent of yeses and nos there are. So with this and figuring out what percent of yeses and nos there are, how can we figure out if something is equal to yes? How can we figure out if something is equal to yes? How can we figure out if something in vector x is equal to yes? How can we figure out if something in vector x is equal to yes? How can we figure that out? How would we figure that out? Correct, KP, you got it right there. X, whoops. X equals yes. There we go. So now we have x equals. Great job, Kirsten, right there too. Excellent work. Like, keep up the great work, everyone. Just keep practicing. If you don't know it, take a moment, pause. Especially if I'm doing the videos like this, just pause when I ask the question. See if you can get it. We will answer the question, so you will hear the answer. But see if you can get these as we like to say, little bits. So now what do I want to do? Is I want to find out what percent of yes there are. There's a quick way to do this. There's a long way and a quick way. How can I find out what percent of this is yes? Now, yeses and nos are zeros and ones inside of R. So how can we possibly figure out the percent of yeses? There's a quick way. There's a very, very quick way. How could we figure out the percent of yeses? How can we figure out the percent of yeses? There's a pretty quick way on this. Percent, I don't know percent. There's a percent I in percent. I don't know percent I percent. Good guess there, KP. Think about this. I want to find out what percent, like what average, like what's the average amount of yeses. That's a hint right there. Yes, no, great work right there. That's the exact answer. Take the mean of this vector. And does that make sense right there? If you take the mean of the vector, it works because these trues and falses inside of R are just ones and zeros. So think about there's 5 numbers, there's 3 ones, 3 divided by 5 is 0.6, excuse me, 60%. So trues and falses are zeros and ones inside of R. Like when R hears true, it just hears 1. So we could just take the mean of that vector. If you take the sum of this vector, what will the sum of this vector be? Just good knowledge checks right here. What will the sum of that vector, which all of this is that vector. This is that vector, this is that vector, this is the mean of the vector. What would the sum of that vector be? Which is a good way to find out how many trues there are. Well, no, we're not going to use sum. It'd be 3. Great job right there, Kirsten. So sum of the vector gets 3. Mean of the vector tells you the percent of trues. So you can take a logical vector and find out what percent of the time the condition is met. So really, this will work almost as is. We'll worry about the error message here in a second. But we can go here to fun, and then I'm going to take and name it prop of donors, and then I'm going to take this, and I'm missing one portion of it right now. I'm missing one thing to end the function. What am I missing to end the function other than saying input X right here, which that is capital X. You can highlight to make sure it's the same. What am I missing to kind of say, hey, that's the end of my function. I want to finish the function and move on and do something else. What am I missing? To be like, function over when this is right here. What am I missing to say, no more function? Leave function world. Return from Vegas. What am I missing right here? What am I missing? Return, KP, great work. So we put a return at the end of our function to return this value, and we can check to see if this works. Now we're going to run to a problem because that says 0. Now, this is where we need to add in the warning message. Now, let's think about how we're going to do this right here. We need to see if somebody put in something in either yes or no, but case sensitive. So it has to be case sensitive. So let's define something of interest. Let's say interest equals the vector yes, capital yes, or no. It's like the way I like to do in little bits. And so we are going to say this is what we're interested in. So now let's ask, are, so many ways to do this. I don't want to do it too, I want to do it like the smallest. I already have like 2 ways in my head. And I'm like, that's like longer. Because we can say with our vector x, which is this, is the vector x contained in the vector of interest. There we go. And so those values are contained in. Now, I wish I could, the way to see if there's at least one true right here is to say sum of this is what? I want to see if there's at least one true. To see if there's like a yes or a no in that vector to see, which is kind of, I think it's what it wants. I mean, it'll work. It's what it kind of wants. But how would I say, is there at least one yes or one no here? Properly written. How would I write that? Like the sum of that vector is greater than, exactly. Kirsten, do you have a better way? Because that'll do it. And the reason I want to say, like, why am I doing it this way? You'll see in a second, is because if I have an if right here, it has to take something of length 1. If you put in here something of length 2, it should get mad. Ifs take things of length 1. So it'll probably get mad, and it says has greater than length 1. So I have to get something of length 1 right here to see, is there at least one yes or one no? Does that make sense? Like an if takes a true or a false. You can't put something of length 2 or greater inside of here. An if takes something of length 1. So I could just call this logical check. And that's my check right there to see if there is a true or a false. And I could run this right here with the logical check. I didn't store logical check. There it is right there. Does that make sense, this code I'm writing? I'm going to say these are the things I'm interested in. Is there at least one of those things in the vector? And this returned true. So we want this right here. But you know what, Kirsten? We want the message to return if none of them are in there, right? So what should I change this to? Please tell me people are stuck. I don't want to go too quickly here. I want the message to come back. Oh, Caitlin, great to see you here. Awesome. Yeah. I want it to return if none of the things are there. So I want this message to pop up if none of the values are in the vector. So what should I change this to? I want the value to pop up if none of those things are in the vector. Not if, like I'm rethinking it. There's many ways to change this. Actually, that's what I realized as I was saying it, Kirsten. I could just do that right there, not the logical check. Or the first way that popped in my head is to do equals equals 0. So that's going to say if there is none of those things. So both of those ways are great ways. Flipping it with an exclamation point, because all exclamations do. That was like, I thought of that right before you said it. Exclamations just flip trues to falses. So we could say like, if it doesn't meet the logical check. So I think that's a great way of doing it. Like, here's our logical check to see if there are the things in there. And this is saying if we don't meet the logical check. So right now we meet it. This is saying if we don't meet it. So now we want to take right here and put a warning. I like to open this up and go warning and say, please enter a vector. Did you know? Let's say, did you know? Did you know? You need yes or no, case sensitive. Sure. Okay. So now we're going to take all this code right here, and we're going to put it right inside of our function right here. We're going to reformat the function with Control-Shift-A or Command-Shift-A on a Mac. We're going to run our function, and there we go. How does it look? What are people's thoughts? I guess we're going to do B real quick right here, or try to. But does this make sense on the process by which we made the function? We made the warning, and then we inserted the warning into the function. What are people's thoughts? That was a little bit tricky right there. And we have the next thing. Good job, Knox, right there. What are people's thoughts on this? Makes sense, Noah. Great work. These are tricky. We're going to be doing a lot of practice today. Today is a work day in both classes. Work. The donor data set in red class looks at the donations behaviors of 19,000 people. On the mailing list of event and charity, use aggregate as well as your function to produce a data frame that gives you the proportion of donors, blah, 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 blah. And left arrow the result of the running aggregate into A, then print the contents of A to the screen. Also print the rows sorted by donate column via Always sort A. If you didn't know about aggregate, make sure that the same data frame would require a triple nested for loop. Oh yeah, my gosh. So wait. Okay. Oh, because we have our user-defined function. So the proportion of people. So we've got a user-defined function right here. So I think I know what it's saying. Okay. So we've got the donor data frame. And with the donor data frame, and it's showing right here the proportions right here. So we want to take, because I think it's showing us, yeah. And we need to store A, right? Left arrow the results of running aggregate into A. Yeah, okay. So the aggregate function, once again, is we're going to take aggregate, and we want to aggregate, is it donate? There it is right there, donate. And we're going to aggregate donate. This is pretty crazy. We're going to aggregate donate by these values. There's what we're aggregating it by. And then we want to go here to data equals donor. And then fun, capital fun, equals prop of donors. And we don't put the thing on it. There it is. Beautiful, beautiful. Whoa, craziness. And that's the start of it. Oh, and then it's sorting it, I think. Ours is sorted a little bit differently. Make sure we get the same values. And then does this, and then this is the tail of it. So that's the tail of it right here. Ours looks a little different. Scares me. Scares me right here. It says, let me see what it's sorted by. Also print, and then order it. Order it. Okay, they are ordering it. Let's order it. So they're storing it into A as a data frame. And then we could just take a look at A over here, and then we could order it. Yeah, that's got it. So if you look at the values right here, that's tricky. But it's really cool what we can do. So let's show the ordered data frame, and then show the answer. So we'll put it down there. There's the ordered data frame, and there's the answer up there. And we'll put it right to where it shows right there. There's the confirmation on our answer. Are there questions about this? Is kind of going back to the start of this question where I talked about using aggregate and how aggregate works, that you take a Y variable of interest and then you can subdivide it into groups of X. And instead of doing a triple nested for loop right here, you're able to aggregate and get all the values of donations. So you could look and find out which people are most likely to donate by which group. I mean, does this seem useful to a business to say, okay, we've got these variables. We've got, are people a homeowner? Are they in an urban city? Like, is it rural, urban, or I don't know those other values. We've got an overlay source, and we want to figure out who's most likely to donate. I would also want maybe how many individuals are in here, which I think, is it N or count? I got the same answer, but Canvas marked the question wrong. What is the question asked on? Let me look at the Canvas question on it. And then we're going to do some more 201 coming up here. So 201, stay tuned. Oh, did I mark this? I think I marked this as a question, right? Yeah, we marked it. Good. Let's take a look at the 201 question. Mubot just talking away there in the chat. Let me look at the question. Based on question 4, enter the 3-letter code Giving the combination of overlay source homeowner that has the smallest proportion of donors. Enter the 3-letter code that has the smallest proportion of donors. So, you might have to message me, but enter the 3-letter code that has the smallest proportion of donors. Does that make sense? This, don't worry, it should be right. If you think you got it wrong, like message me and say, hey, Brian, check out my quiz. But I checked the answer. Everything looks good. But using this right here, we can find which of the 3 has the smallest proportion of donors. Does that make sense? Let me know if you have questions, but it is working. This is correct. Don't put the answer in the chat, but it is correct. Like, put it this way. What would be the 3-letter code for the group that has the highest proportion of donors? So what is the 3-letter code for the group that has the highest proportion of donors? We're not going to put the other answer in the chat, but let's put this one. What is the 3-letter code for the group with the highest proportion of donors? And you could also sort the data frame you made. What is the 3-letter code for the group with the highest proportion of donors? So here's the highest proportion of donors. And what's the 3-letter code for it? What? I like that there's a question mark on that, Noah. It's like MH. No, but it's MH question mark. That is correct. So let me know if you have questions or if you're stuck on it. But it looks like check out how the other one works. I think you'll get it. But great work. We're going to do a little 201 right here. And we're going to do some more functions in class today and more for loops. Stay tuned. Great work right there, everybody. Time for a little more 201. Some fat and calories question. Let's go back over here and do the fats and calories. Time for 201. Cooper's excited right here. Cooper, some 50 points for more 201. We're going to do a Kahoot tomorrow night. Tomorrow. Let's go right here. The fat and calories question is going to take me a minute to pull it up. The fat and calories question. I was tossing and turning all last night. Ugh. Get some sleep. 201. Fat and calorie question. Let's do it. I get my yawns between questions. I'm going to get my second cup of coffee between officers in class. Fat and calories question. Our decision tree is going to be on this exam. They are on next exam, if I am correct. Leela, good question. They are on next exam. Is that correct? I'm going to make sure. I might need to look at stuff. They should be on... like, I can double check right here. Let me double check. I don't want to misspeak. Let me double check. I'm pretty sure they're on next exam. They are on next exam. They are on next exam. Next exam starts with decision trees. That is correct. So, yep, just double checking. Exam 2. They are on the next exam. Yeah, there we go. I see them. Yep, they start next exam. There they are. Good question. Thank you for asking. Want to make sure. That's a residual plot one right there. You want to know the question like which residual plots? I've one time said something wrong. So for 2 bonus points, we need 10 hours. And I think that's right, Cooper. I think according to the syllabus, that is correct. And so I'll be going through and checking. I believe according to the syllabus, that is correct. Okay. Thank you for being here, Cooper. Thank you, everyone, for being here. Let's go check out that fat and calories question. If you misspeak and you put wrong information out there, everyone hears it. No! So now, let's take a look at the fat and calories question right here. So the easiest way to do this for 201, what 3-letter word are we going to use, 201, to do this the easiest possible way? What 3-letter word are we going to use to do this the easiest possible way? The easiest way to do these questions is going to be right here with jump. Jump's going to make life nice and easy. So let's go ahead and take and go copy to clipboard and hit Control or Command C on a Mac or a PC. Now that we've copied it, we're going to go over to jump and take a look. Are there column names here? Type Y or N in the chat. Are there column names? Are there column names? Y or N in the chat. Are there column names right here? You can also see when you copy it. Are there column names? There are. So we go to Edit, paste with column names. Make sure to do this because if you don't, you're going to have a bad time. So this is what happens when you paste with column names. And if you don't paste with column names, it now thinks your data is not quantitative because the label went in the first row. It thinks your data is what? So this is the error. If you see this, this is wrong. We can't do regression on this. So we're doing a little bit of review of the concepts here too. It thinks your data is what kind of data format. It doesn't think it's quantitative right now. It thinks right now because you didn't paste with column names. And if you don't paste with column names, just restart. Close your sheet, restart. There is a way to fix it, but it's a lot more work than just opening a new sheet and repasting. It doesn't think your data is quantitative right here. This is the error. A lot of people have this error. It thinks your data is what kind of data type. It doesn't think it's quantitative. It thinks it's what. So we have quantitative and what? Review of concepts. Quantitative is over on the left for blue. It thinks your data is categorical right there. Great answers. Thinks it's categorical. And what is the first condition of regression? Who knows that first condition of linear regression? Does I see in class, I say QQ straight enough, no outliers, plot doesn't thicken. QQ straight enough, no outliers, plot doesn't thicken. The first, Leela, great work right there, is QQ. Maybe watch some of the review videos, or maybe I put it in there. 2 quantitative variables. So if you don't have 2 quantitative variables, you're not doing regression. So we have to make sure the variables are quantitative. Make sure to paste with column names. Open a new sheet, paste with the column names. There's a shortcut to it that I know. Okay, so now that we know we have the data in here correct, the rest of it is simply going to analyze, and it wants us to do a prediction from fat. Predicting fat is the y variable. That's the y variable of interest. So that is the predicted y variable. Then we have here the intercept plus the slope times the x variable. So this reads y variable of interest, has the hat on it, it's predicted y variable, equals some intercept plus the slope times the x variable. So analyze, fit y by x. We are going to predict the fat of a burger from the calories. That was analyze, fit y by x. Analyze, fit y by x. We are predicting fat from calories, and here is the graphic right here. So let's just leave this over here on the screen and kind of take a look at these questions. They kind of flip it, so let's be careful right here. Explain why you cannot use this model to estimate the fat content of a burger with 600 calories. So when they first make a model was created to estimate the number of calories when fat is known. So they whatted the x and the y. Do you see it? Up here, they're saying they made a model to estimate the number of calories from the fat. So down here, we're estimating the fat from the calories. So they've flipped them. Does that make sense? Like the top model says, let's estimate the calories from the fat. So they're using calories as y to estimate calories, to take a prediction of calories, using fat to explain calories. Down here, they're saying, let's change the model. So the regression model up top was for predicting calories from fat, not the other way around. So the regression model up top was for predicting calories from fat because they're estimating calories from fat. So now we've made the proper model, and we're almost there with visualizing it. To get the answers to this question, we need to click the red arrow, and then we need to click fit line. So we're going to click red arrow and then fit line, and it'll actually fit the regression equation for us. So here's an important thing to know. In notation, the value of the intercept is what? Now it's negative 13. Don't forget that negative. That's a quick mistake to make. It's negative 13, but what is it in notation? Think it's when x is equal to 0. So what is it called in notation? The intercept is known as what in notation? The intercept is known as what in notation? It's down here. It's when x is equal to 0. But so remember, x is equal to 0. That means the intercept is known in notation as what? Now the value is this. We're going to copy paste this value right here. But what is it in notation? So there is the intercept. The intercept in notation is known as something 0. B0, Matt, great job right there. It's B0, and it's when x is equal to 0. So that's what the intercept is. Now the slope is B1 because it's for each 1 unit increase in x. So now we take a look at the slope coefficient right here, which goes with the x variable because it's for each 1 unit increase in x. And we go right here and we enter in the slope coefficient and we do it to 3 decimals. So now we should be okay. Don't forget the negative for the intercept. That could be a problem. Now, the last thing down here is to figure out the fat content of a burger with 600 calories. To figure out the fat content of a burger with 600 calories, what should we do? So we want to figure out the fat content of a burger with 600 calories. What should we do? So we're going to make a prediction, right? We're going to predict the fat when a burger has 600 calories. So we should go to this equation, which makes predictions of fat. And what should we do? What should we do? Jake, good to see you here, Jake. Thank you. Don't miss this class. It's good advice. What should we do? If we want to make predictions for a burger with 600 calories, we should then plug in the value of 600. So we're just plugging in 600 into the equation. This predicts the fat for burger. Aw, Jake, 100 points. I appreciate that right there. People are really nice to me. That's really awesome. I just think we need to be nice to everybody in this world. Well, I don't know. Ignore mean people. That's Brian's advice. If someone's mean, you just kind of say, I don't need you in my life. If someone's mean to you, say, that's cool. I'm gonna go over here. You just stay over here. Let's go walk away from you. It's Brian's advice on how to handle mean people. Round to 1 decimal. We're gonna round down now. Come on, my Pearson. Don't you tell me I'm wrong, my Pearson. Don't you go breaking my heart. Check the answer. Whoo! Don't you go breaking my heart, my Pearson. Don't do that to us. I'm going to walk away from my Pearson. My Pearson was mean this weekend. I almost walked away, and then my Pearson said, I'm sorry. I'm sorry I was down for so long. And I said, you get one. You get one. Everyone gets one. Let's go check out that residual plot question. So, Met, what does your residual plot question look like? He says, Chapter 7 quiz. It's like find the residual plot from. There's a lot of good ones on there, a lot of tough ones. These are some of the toughest questions. How to find the fanned out. Yeah, it's Chapter 7, right? I saw one that looked like that, and I thought it was it, but then I thought it wasn't. That's what I do. I think something, and I think the otherwise. Is this right here, right? It's on the homework. Is it this one right here? I believe it's this one, right? I believe it is. So like fanned out patterns. I believe it is this one. 114. It is awesome. Great job, Matt. Okay, let's take a look at this question right here. And yeah, a little chill music. Let's do this. Okay, so what is a residual plot? A residual plot lets us examine our regression. Now, if we have a regression line, a regression line is known as the line of best fit through the data. It does things like minimize how far it is away from each point. So a regression line looks like this. Now, a residual plot shows us all the residuals. It's really easy to make a residual plot. To make a residual plot, all you do is take your regression and make it flat. So we're going to take the same exact regression line and then just go right here and make it flat. Now it's a residual plot. How's this looking, Matt? See you tomorrow, Cooper. Now it has 0. Anything on the line would have a residual of 0. We could even go in here and erase the grid lines, because we don't really need those, and kind of redraw them. But is this making sense? How do we make things into a regression plot? How do we make things into a regression plot, Matt? How do things become a regression plot? I mean, a residual plot, excuse me. How do things become a residual plot? And that's the residual plot for it. That's the exact residual plot. You take the line, you make it flat, because then we can see the vertical distance things are away from the line. So now we can see how far above or below things are. Does that make sense? So this is a residual plot. It usually says like residuals over here. And this is the regression plot. You take the line, you make it flat. Exactly, and this is how far it was away, right? So the vertical distance now is how far the predicted is away. I like to say residual wrap. So residual equals actual minus predicted, and the observed is the actual right there, and the predicted is the predicted. So the residual is the actual minus predicted. So here, oops, wrong color. If we talk about where something is actually at, like this point, it's actually there, but it was predicted to be here. So that point has a what residual? So that point's residual is what, Matt? That point's residual is what? That point in yellow that I've highlighted has a what residual, positive or negative? That point has a what residual, positive or negative? So that point I've highlighted in yellow has a what residual. And so you can see it in both plots. Like you can see it in the regression plot and you can see it in the residual plot. And then think about what that means. Since it has a positive residual, its actual is higher than its predicted. Does that make sense? So if you look at where it's actually at, which is the dot, it's positive. Yep. So it's above the line. Positive means that its actual is higher than its predicted. Negative means its actual is lower than its predicted. And if it has a residual of 0, it would be on the line of prediction. So then its actual and predicted would be equal to each other. So when we think about what this question's giving us, let's look at kind of the first plot right here. Now, we're actually going to do what we just did, but in reverse. So if we have this plot right here, this is a residual plot. Now, remember, a residual plot is the line flat. So let's pretend, and we don't know it looked like this, but let's pretend the regression plot looked something like this. Now, why? Well, the regression plot would have went up or down, right? So here is our line flat in the residual plot where everything on it is equal to 0. And then here is a regression plot where the line goes up. Now, what do you notice about the predictive power of the model? Is it getting weaker or stronger? So down below, we have the regression plot again, just like we did previously on the previous example where we showed the residual plot up top and the regression plot down below. The predictive power of this model is getting weaker as it goes through the model. And here's a hint right here. The predictive power of the model is getting weaker or stronger? Is the power, like how well the model predicts the points, getting weaker or stronger? What do you think? Is it getting weaker or stronger? The predictive power of that model is definitely getting weaker. It's getting weaker because it's getting more spread out. Exactly. It's like scattering out. We want a model that's kind of tightly clustered. So the model is getting weaker in its predictive power. And that also goes to kind of correlation, that it's going further out. So the fanned out pattern indicates that the model is not appropriate. The model's predictive power decreases as we increase across the values of x. Next one right here. It might get me on this one. Let's see what they say. It might be that. This single point, yeah. I didn't know if they're going to acknowledge that point. They should. That is an outlier. So when you think about our conditions, Q straight enough, no outliers, plot doesn't thicken. This one failed, plot doesn't thicken. And then this one was an issue of an outlier right here. So this had an outlier issue, and that's a bit of a problem. The next one is kind of reverse of question A. Question A showed a model that got weaker. Question C shows a model that gets stronger. The predictive power of the model increases, and we want constant predictive power. That's the plot doesn't thicken. Now, this might sound counterintuitive, but a good residual plot, which that one's probably not going to show. A good residual plot looks completely and utterly what? Kind of our last question of the day. If I had a good residual plot, like if I had a regression that looked like this, and then I turned it into a residual plot, think about how this would look. So there's my regression. Looks pretty good. No problems, no outliers, no plot thickening. A good residual plot, because here's the residual plot, would look pretty what? I know it's counterintuitive, but a good residual plot. Oh, Matt, you got it. That's where the 100 points. It would look random. It would show no patterns. It would look pretty random. And you see up there a really good residual plot. It just looks pretty random. It doesn't have any patterns associated with it. And there's our regression. There's our residual plot. It shows the same thickness throughout. We don't see any extreme outliers, and it looks random. Well, great job, everybody. We're going to do some more work in 474 and 475. 100 extra points. Until then, we'll be starting class here in 8 minutes. I'm going to go get more coffee. Bye for now, everyone. Bye!